problem 6, we need to write an equation to represent an investment of $1,500 which earns 3% annual interest, so 3% per year. So our initial value, our initial amount of money is $1,500. The money is accruing interest, meaning that the money is growing. So because we are increasing the amount of money, we need to multiply by 1.03. And we're not given the number of years, so we can use a variable to represent the number of years. So that would be option C. Looking at the other options on this one, we know it would not be 0.03 because this would tell you that you are decreasing the amount of money over time. Similarly, option D would also tell you that you're decreasing the amount of money that you have over time. This option, you're increasing your money. In problem number 7, this parabola is being shifted by the amounts that are shown here. 6 units to the left, 3 units down. First, let's start by writing down what the vertex of the given equation is. The vertex of this given equation is 4, 2. If we shift the vertex of the parabola 6 units left, we would subtract from the x value, because left and right is in the x direction. And if we shift the parabola 3 units down, we would go -3 in the y direction. Our new vertex, 4 minus 6 is -2, 2 minus 3 is -1. We need to figure out which of these equations has a vertex at -2, -1. Automatically, we can cancel out these options. X minus h squared plus k is our graphing form of a parabola. So with the x value of -2, we would want it to be x plus 2 squared, and then plus k would be -1. So answer is D. In problem 8, we're asked to determine which of these is equivalent to this statement. So let's start with each option and determine whether each of these is equal. If we condense the first option here, log base 5, subtracting logs means we need to use the quotient property of logs, so that would give us 48 divided by 2, which is 24. So it actually looks like this is the correct answer, option A. In problem 9, we have a log equation, and we're reminded here to check for extraneous solutions. Remember that you cannot have a negative argument in a log equation. So we first notice here, both sides of our equation has logs, so that's an important thing to know before we start. In order to solve this equation, first step is to condense the logs on the left side. So using the product property, because we're adding logs, we can multiply these two arguments. So v times v plus 2, and we don't need to change anything on the right side. This expression can be simplified to v squared plus 2v. And now that we have a log on the left and a log on the right with the same base, we can set this argument, v squared plus 2v, equal to this argument, 48. So to solve this quadratic equation, we set it equal to 0 and factor it. The factorization here we can use positive 8 and negative 6, so v plus 8, v minus 6. This quadratic equation gives us two solutions, negative 8 and positive 6. But remember to check for extraneous solutions. The negative 8 creates a negative argument in our problem, so it is extraneous, so 6 is the only solution. In problem 10, find the zeros of this function. The zeros, the synonym of zeros is x-intercepts or roots. So f of x we can treat as our y, and to find the x-intercepts we can set y equal to 0. This quadratic equation can be solved by factoring using values of 9 and negative 4, so x plus 9, x minus 4. And remember, the zero product property tells us that either x plus 9 must equal 0, or x minus 4 must equal 0. So our solutions are either negative 9 or positive 4. So looking at our options here, D is the correct answer.